We're going to take a look at section 5.5 and a few of the problems that you're going to have on this week's homework. So the first type of problem that you're going to encounter is the difference between rational numbers and irrational. And we've actually discussed this some in previous chapters, but a rational number can be written as a fraction or a ratio. So let's think of some of the numbers that this would work. So any of your integers. So remember that an integer can be written as a fraction. You can just put it over 1. So the same thing works for a negative number. You can do negative 12 over 1. So either way will work just fine. Rational numbers also include all of your fractions and their decimal equivalents. So like 1/3 is equal to 0.333, and so on. And so a lot of times you will see this written as 0.3 with a bar over it. So it doesn't matter in what form, whether it looks like a fraction, it looks like this repeating decimal, or it has this decimal with the bar on the top. So repeating decimals are also rational numbers. Repeating decimals. You also can have repeating decimals like 0.21212121 and so on. You'll see that it could be written as 0.21 with a bar over it. That's also another form of a repeating decimal. And then you also have terminating decimals. So any type of terminating decimal would be like 1/2. So and the reason, I'm not sure why my pen doesn't want to work here. So let me just see. Okay, so I think I got my pen worked out here. So like 1/2. 1/2 is a terminating decimal because it stops, so 0.5. 3/4 is 0.75. Okay, so all of those are rationals. Now, irrational numbers cannot be written as a fraction or a ratio. And so like a couple of examples are pi, which is like this infinitely long number. And then also E is another mathematical number, and it's this number right here, and it goes on forever. And so both of those are irrational because you can't put them in fraction form. You also have what I like to call as fake repeating decimals. And I'll show you what that looks like. So fake repeating decimals, let's say you had like 0.2121111121. So it looks like it might be repeating because there's this pattern, but that is a fake repeating decimal, and it is that is an irrational number. Okay, the other thing is that you can have square roots of prime numbers. So the square root of 2, that is an irrational number. If you were to get your calculator, and this is how you can test it, if you were to say the square root of 2, this is the number. And so you see how it goes on and on and on forever. So then you would know that if there is no end in sight to that decimal, then it's going to be an irrational number. Okay, so hopefully you've got rational versus irrational. All right, now the next thing is we're going to have to talk about perfect squares. So you kind of need to know a few of the perfect squares. So this is just a list. 1 squared is 1. So that also means that the square root of 1 is equal to 1. 2 squared is 4. So that means the square root of 4 is 2. 3 squared is 9. Square root of 9 is 3. And you can kind of figure this out, but this would be 16, 25, 36, 49, 64, 81, and 100. So that's the first 10. So this right here, this list of numbers is called your perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on. Those are called perfect squares. Now, they're going to become very important in the next part. So the next part actually talks about radicals. So radicals are going to be your square roots. Now, if you have the square root of 2 times the square root of 2, that is really the square root of 2 squared. Now, what happens is that this square undoes that square root. They kind of undo each other. And so really all that you get is 2. So that's your answer. So again here, if you have the square root of any number multiplied by itself, then you get the number that's underneath that root sign. So in this case, this would be 79. So you have a few of those. Those are really simple. And that's just applying the basic rules of radicals. Okay, so now you're going to have several that are going to be where you want to simplify radicals, and this is where you want to kind of have your list of perfect squares. So 4, 9, 16, 25, 36, 49, and so on, okay? So if you have that list of perfect squares, that's going to help you. So what we want to do here is that we want to simplify what's under the square root sign. So we have 5 times the square root of 12. Well, what I want to do is I want to break 12 up into factors. And I need one of those factors to be a perfect square. Okay, so what I'm looking for is one of these numbers that will divide evenly into 12. And so I'm looking at this and I see that 4 will divide evenly. So I can break this up into 5 times the square root of 4 times the square root of 3. So 4 times 3 is 12. So the rules of radicals allows me to break up the square root of 12 into the square root of 4 times the square root of 3. Now, what is the square root of 4? The square root of 4 is 2. So really, this is 5 times 2 times the square root of 3, which 5 times 2 is 10. So your answer is actually 10 times the square root of 3. So if you're asked to simplify a radical, that's what they're looking for. And so you would put this answer, the 10, you would put that answer into that math pad. And so just make sure that you type it in correctly. Okay, let's do the same thing here. Let's do 2. Now 250, I know that that'll work as 25 times 10. So let's do the square root of 25 times the square root of 10. So that's 2 times, the square root of 25 is 5, times the square root of 10. So that would be 10 times the square root of 10. Now, you want to make sure that you've simplified all the way. So you want to continue to look and you want to see, are there any more perfect squares contained in 10? And so you have to look at the numbers that are less than 10. So 4 will not divide evenly into it. So, so you're okay. 9 and 4 are the only 2 options here. So this would be as simplified as it gets. Okay, now we're going to take this idea of simplifying radicals a little bit more. So what they do is they just get uglier. So now we have this expression, 8 squared minus 4 times 6 times 2. Now remember the order of operations, okay? So you have parentheses, exponent. Remember, multiplication, division goes together, and addition, subtraction goes together. So what I'm going to do is I'm going to do everything under the square root sign in this order from PEMDAS. And so parentheses, you can kind of consider this root sign to be a big parentheses. So we need to do everything that's underneath it first. Now we're going to do exponent next. So here's an exponent. 8 squared is 64. So I'm just going to do this in one step at a time. Okay. So now I have square root of 64, and you see the rest here. Multiplication, division is the next. So I'm going to do this in order from left to right. So I'm going to say 64 minus 24 times 2. And that's going to be 64 minus 48. Okay, and 64 minus 48 is 16. Is that right? Yeah. So then you have the square root of 16. Now, that's a nice, pretty number. The square root of 16, because 16 is a perfect square, is just, well, you don't have the square root. This is going to be equal to 4. So 4 is going to be your final answer. All right, so just make sure that, if you need to stop the video, rewind that and look at that again, but you're just doing PEMDAS in order. Okay, they're going to continue to get a little bit uglier each time. So now we have this really ugly fraction that also contains this radical sign in it. So that's square root. So what we want to do here is, you can kind of consider this to be 3 terms. We have 1 term, 2 terms, and 3 terms. So the rules of algebra and math say that if you do the same thing to every single term, then it's legal. But you have to do it to every term, or it's not legal. So what we can do then is we are going to look for ways to simplify this. So I'm going to look at the 12, this 3, and this 9. And I want to look at a common factor. So the greatest common factor, GCF, we learned that last time, of 12, 3, and 9, well, that would be 3. That's the greatest common factor. So what I'm going to do is I am going to divide each term by 3. So you can, if you need to say divided by 3, divided by 3, divided by 3. Okay, so what we have here then is 12 divided by 3 is 4, minus, now 3 divided by 3 is 1. So I just have 1 times the square root of 5, which that's just the square root of 5. 9 divided by 3 is 3. Now you also want to just take a look and make sure you don't have any more common factors, which between 4, 1, and 3, there are no common factors. And then you want to also look at the square root. If you can simplify this square root of 5, just like we did in the previous problem, you have to do that. In this case, that's everything. Okay, so now whenever you go to put this into the computer, you need to first choose the fraction. So choose your fraction. So it looks something like, it'll have like a square over a square. Okay, then the second thing you're going to do is you're going to click into the top. Click top box. So whenever you click this top box right here, then you are going to type in 4 minus the square root of 5. Then you have to click the bottom box. Okay. So then once you click into that bottom box, you can just type in a 3. So it takes a little bit of practice. If you just have a really hard time with that whole math type thing, I don't want you to stress over it. If the computer won't accept your answer, feel free to just write your answer down and email it to me or text it to me, take a picture of it, and that'll work. I can grade it then. Just know that you're not going to get 50 million tries on that kind of, you get 5 tries on WebAssign. So, but if all else fails, do that, and I'll be glad to help you with that. All right. The ugliest of these problems is one like this. So there's a lot going on here. You have to remember PEMDAS. You're combining all of these ugly things together. So what I'm going to do first is I'm going to concentrate on what's underneath that square root sign. So 14 minus the square root, and I'm going to say 8 squared is 64. 4 times 11 all over. I'm leaving everything else the same. Okay. So then I'm going to say 14 minus, this is 64 minus 44 all over. I'm going to go ahead and do 2 times 6. Well, we won't do it yet. I don't want to confuse you. Okay, so then we're going to continue finishing underneath that square root. We have 14 minus 64 minus 44 is 20. So you have the square root of 20 all over 2 times 6. Okay, so now we're almost done here. So what we can do is I'm going to go ahead, that's everything that's under that root sign, and so now I'm going to do my 2 times 6. So that's 14 minus the square root of 20 over 12. Okay, now you have to simplify everything that you can. So we need to simplify the square root because there's a perfect square inside of that as a factor. So we're going to have 14 minus the square root of 4 times the square root of 20. No. Square root of 4 times the square root of 5. Sorry about that. So over 12, and that's going to be 14 minus 2 times the square root of 5 over 12. All right, almost done. The only thing we have left is to look at our terms here, and if you have a greatest common factor, we need to divide it out. So the greatest common factor between 14, 2, and 12 is 2. So I'm going to divide every one of those by 2. So I'm going to get 7 minus, now 2 divided by 2 is 1. So I have the square root of 5. All divided by 12 divided by 2, which is 6. And that is finally your final answer. Okay, 7 minus the square root of 5 times 6. All right, and I want to make sure, let me go back up here, make sure I did this correct. Yeah, I think we're good. If I did something wrong, I'm sure one of you will tell me. Okay, so I think that's everything. The last one, you have a few word problems, which these are meant to challenge you the most. You only get this word problem, that's your question. The key to this is knowing a couple of different things. 1, draw a picture. And then 2, you have to know this formula. So how far from the base of a building must a 10-foot ladder be placed so it reaches 6 feet up the wall? So you kind of end up getting this triangle type. Here's your ladder. Your ladder is 10 feet, okay? And then it goes up 6 feet, and they want to know how far is the base. So this is called the Pythagorean theorem. and Pythagorean theorem. And you should be given this in the explanation in the chapter, but you kind of have to hunt for the formula. So I wanted to go ahead and give it to you because you'll use the same formula on several of these problems. So all you have to do is plug in the numbers. So if I let this A and B have to be your shorter sides, and then C has to be the longest side that is across from this right angle. Okay, so that's the only catch to this. So A squared would be 6 squared plus, I don't know what B squared is, so I'm going to say B squared is equal to 10 squared. Okay, so that's 36 plus B squared is equal to 100. Now, if you remember from algebra, to solve, we're wanting to know what B is, so we need to subtract 36 from both sides. So we get B squared is equal to 100 minus 36 is 64. Now, to get rid of a square, you do a square root. So we're going to take the square root of both sides. And you get B is equal to the square root of 64, which is 8. So how far is the base? It's 8 feet. Okay. So I know that's kind of fast, but there are several other video examples as well, and you can go over those and take a look at those in the text. So if you have some problems, be sure to reach out to me, send me an email, watch this video back over again. Hopefully it will all work out just fine. All right, that's going to do it. Thanks so much.